Good morning, everybody, or afternoon, depending on what part of the United States that you are in today. I'm Howard Grimes. I am the CEO of the Cybersecurity Manufacturing Innovation Institute, or CyManII. Next slide, please. We are we have launched in September 1 of last year. And we have two major objectives for today. The first objective is to relay to all of you our very robust overview of the national roadmap that we are constructing for cybersecurity and U.S. manufacturing. So we will be doing that today in this webinar. And the second objective, which is even more important in my mind, is to encourage, entice, incentivize all of you to participate in a series of upcoming workshops. You'll get a lot more detail on this later, but fundamentally, we are about halfway through the roadmap process. And to complete that process, we need significant engagement with all of you. A couple comments, logistics as we go forward. This is a webinar, so we encourage you to solicit questions and queries in the chat box, and we will moderate that at the end of the session. Second point is that Sarah Spencer is on. She is your triage person. If you experience technical difficulties during the webinar, please reach out to her directly. And that's it. So what I'm going to do is give you a very brief high-level overview of the Institute, and we will take it and start peeling the onion, so to speak, from there. Next slide, please. So our challenge is well known. U.S. manufacturers need to digitize in order to gain energy efficiency gains, to be globally competitive, and to increase their bottom line. The problem with that, as you increase productivity and profit by that digitization process, you exponentially grow or increase your cybersecurity attack surface area. So the challenge that CyManII faces is to really come up with a next generation approach to cybersecurity that reduces that cybersecurity attack area while reducing energy use and thus protecting against cyber attacks. Next slide, please. So what we envision is a secure by design manufacturing ecosystem where we connect three planes: a cyber plane to the physical plane and to an energy transaction plane. And by doing so, we create a new business model for cybersecurity investments. In other words, investing in cybersecurity innovations that CyManII will introduce over the next years that will significantly decrease the cyber attack surface area, but also allowing U.S. manufacturers to capture profit, if you will, by lowering their bottom line, by lowering their energy usage. So that interconnectedness of, giving a strong financial incentive to really transform the marketplace. Next slide, please. Our vision is to introduce a cybersecure energy return on investment that will lead to energy efficient manufacturing and protect the supply chains. And that in turn secures and sustains American leadership in global manufacturing competitiveness for decades. Our vision is really captured by this Epsilon Pure cybersecurity that is energy efficient, it's pervasive, it's unobtrusive, it's resilient, and it's economical. Next slide, please. We're outlining our six integrated technical areas here. The first one is what you're engaged with now, which is road mapping. We are also in a parallel fashion, driven by Crystal Castillo, doing a baselining effort so that we can measure our impact, to the industry. We'll go through each one of these in more detail as we go on, but we introduce what we call the secure manufacturing architecture. This is essentially that next generation cybersecurity approach and innovation. We create a shared research and development infrastructure that creates a space for us to test and validate SMA in specific applications for small, medium, and OEMs. We have a concerted effort to really change the scalability of how we detect, mitigate cyber vulnerabilities. And we have our pathway towards sustainability, which is to stand up a company ultimately that we'll call TrustWorks as a service. And all of these things drive us towards that vision for cybersecurity, that is Epsilon Pure, that'll secure and sustain American manufacturers for decades. Next slide, please. I want to now introduce our Chief Operating Officer and Chief Information Security Officer, Ken Fowler, who will walk through some of our operations and where we stand in those processes.
Well, good day, everyone. I'm Ken Fowler, the Chief Operating Officer, as well as the Chief Information Security Officer for CyManII. I want to take a couple of minutes and talk about our membership. Next slide, please. We have a very broad and diverse set of members that span from the West Coast to the East Coast, to every corner of the nation. We have a great group of team members that comprise members from universities, from industry, from government, as well as from nonprofits. Next slide, please. So currently we have 31 members. We have partnerships with 3 different national labs: Sandia National Labs, Oak Ridge National Labs, and Idaho National Lab. We have 114 specialized cyber research and development facilities. We also have 30 manufacturing test beds, and we have 71 individuals collaborating on CyManII technical teams. Even though we're a young institute, we are off and running. Next slide, please. So we have 4 different levels of membership. The first is a managing member, where we have representation on the governance board for leadership on strategic direction, planning, prioritization, and on key programming initiatives. We also have strategic membership, which is where we have members participating in road mapping efforts and helping to make strategic decisions made regarding investments, technical focus areas, as well as on projects. We also have collaborative members who have access to CyManII members only information sharing portal. And then finally, we have community membership, where we have discounts on CyManII sponsored symposiums, workshops, conferences, and technology showcases. For more information regarding membership, please look at our website at cymanii.org/membership. Thank you. I'd also like to turn it over now to Dr. Greg Shannon, our Chief Science Officer. Greg?
Thank you, Ken. So next slide, please. There we go. So just want to give a little bit of context as you hear these 6 areas of work that we've been working on, and the road mapping in particular. Want to be clear about what our North Star is for CyManII, and this has been the case early in the proposal days, and we continue to see this as guiding the type of work that we do. One, it's about energy efficient. It's Epsilon Pure, so it's about innovations that are energy efficient. Energy efficiency is one type of innovation that we can protect, but our vision is broad in terms of protecting all innovations eventually that enable to improve U.S. competitiveness. It's about being pervasive. So, if you're going to have effective cybersecurity at a national level, you want everyone using it. You want it to be unobtrusive. You've got to make it usable. Some would say even invisible, but it's got to be then also effective and resilient. That it actually has to work. It has to make it harder for adversaries to be successful. And finally, it has to be economical. And those are our core principles that really drive our technical work in terms of trying to determine which are good ideas, which are ideas that don't maybe quite meet some of these requirements, these principles that we've set forward. Next slide. To kind of really challenge us, we set these impact goals. Howard alluded to them. We want to save a lot of energy. The US consumes about 125 quads of energy a year. About 25% of that is consumed by manufacturing. So our goal is to have an impact where we can help industry save 1 quad of energy cumulatively over the first 5 years or so. We want to mitigate trillion vulnerability instances, or maybe more accurately say, avoid a trillion vulnerability instances, because ideally we want to prevent these or eliminate these before they even reach the field with advanced development processes, and especially through the secure manufacturing architecture. We want to train 1 million US workers. And the idea of training is to make them effective at cybersecurity. It's not that they'll become experts, but on the manufacturing floor, they'll understand how to deal with cybersecurity issues, how to not be part of the problem, how to be part of the solution, and then it's actually saving money. As the state of Texas learned this winter, when and how you consume energy can affect your bills a lot, especially when there's a shortage of when systems are being challenged. And so not only do we want to save actual raw energy, but actually energy that costs a lot. And those are how we help make US manufacturers more competitive. Next slide. What you see here is kind of the layout of our innovation factory, if you will. We're not producing widgets, but we're trying to improve security, improve energy efficiency in industry. So on the left, you see the first 2 integrated foundational tasks that we have, and you'll hear about today, the road mapping activity, which is really the focus of this webinar and the subsequent workshops. But outside of that road mapping work, we've also been making progress on baselining. You'll hear that from Crystal on that. This integrates with research topics that will be coming out as part of an RFP later this spring, once it's approved by DOE for us to release that, as well as the intrinsic innovations that we all bring as team members and member institutions to the table. These will be incorporated into the secure manufacturing architecture. That's Gabriella will be speaking to that. As Howard mentioned, we have the shared research and development infrastructure, SRDI. Curtis will be talking about that, where that's the context, the environment in which we can pilot and demonstrate and validate not only the efficacy of the innovations and the energy efficiency savings, but also the security improvements. And this feeds then into TrustWorks, where that Paris will be talking about for educating industry about these innovations, not only the energy efficiency savings, but also the cybersecurity elements. Part of that is also dealing with coordinated vulnerability awareness. A key challenge in the small and medium manufacturing sector is that they're challenged to understand what they need to be aware of and how to respond to that. And so the CVA is meant to coordinate with other DOE and US government activities in terms of helping industry, especially small and medium manufacturers, be more aware of vulnerabilities and how to mitigate them, especially in their legacy platforms. Ultimately, our goal is to not have legacy platforms be such an issue that the new innovation, the new infrastructure that's being built out over the coming decades will inherently be more secure, more efficient at being able to protect itself against our adversaries. And I think that wraps it up. Next slide. Yep, so back to you, Karsten, or over to you, Karsten, I should say. So Karsten is our lead on our road mapping work.
Great, thanks very much, Greg. And again, good morning or afternoon to everybody joining us today. My name is Karsten DuPont. I'm the program manager for our road mapping effort in support of CyManII. If we could actually go back 1 slide, I just want to cover briefly that this is the agenda. Thank you. Here's the agenda for today. Our time is focused primarily in a series of presentations from the IFT leads, and then we'll wrap up with some comments on the RFP process and some additional concluding remarks. We also have, for everyone's awareness, an optional Q&A period at the conclusion of the presentation at around 3 o'clock Eastern Time. We'll use the chat feature to respond to questions that you may pose over the course of the webinar today. And again, that's completely optional. So we can now go to the next slide to transition us into the IFT presentation portion. And over the next 10 or 15 minutes or so, I will share an overview of our roadmap work. And following my presentation, you'll hear from the other 5 Institute Foundational Task Leads about their ongoing work as well. So we'll start here just very briefly before we get into the CyManII specifics, just sharing some aspects of a typical technology road mapping process in terms of some of the key questions that the process should help the organization address. So for CyManII, our work has thus far been conducted with these types of questions in mind. And the methods that we've used include expert interviews, surveys, and a series of workshops, both previously conducted earlier this year, and I'll talk about those a little bit in a moment, and those to be conducted in a few weeks. And as Howard mentioned, that's one of the key takeaways from today is eliciting a strong response from the group to join those workshops, and we'll share all those details as well. And then the graphic on the bottom of this right slide, on the right side of this slide depicts, again, not specific to CyManII, but some key elements of a roadmap of this nature, guiding investment, aligning organizations, confirming priorities, and of course, communicating with stakeholders. So we can move on to the next slide to discuss research routes. So you'll hear about research routes throughout the webinar today. It's a key term for our work. Really, this is CyManII shorthand for the framework of objectives and supporting activities for all of our work. And this is the core of the roadmap construct. We'll talk more about those later in the slides, and you'll see each IFT lead allude to those and provide some key themes. I just wanted to make sure that this term is clear to the group at the outset. So you see that definition listed here. And I also just wanted to note, because CyManII is in its foundational stages, for those of you who may have had the opportunity to review a draft copy of the preliminary roadmap, or from the discussion today or the subsequent workshops, you may note that some of the research routes are more focused on objectives that are appropriate for this particular stage of institute development. And that may be a little bit more prevalent for some of the IFTs. In other words, there are objectives that may be less specifically focused on pointing towards an R&D effort, but instead are focused more regarding the setup of the institute by way of these IFTs. They should still be viewed in the context of the research routes, and you can consider these research routes to convey filling gaps in knowledge, i.e. this is the work that CyManII has to pursue at the institute level to be able to do all of its work moving forward. You've heard about the Institute impact goals. I will not recap those here, but again, the purpose of these research routes is to drive the Institute toward those bold objectives. We can move on to the next slide. So I just wanted to highlight some key activities in terms of where we've been, and all of these activities that were really completed in the first 3-4 months of work as the Institute was launched last fall. So as I mentioned in an earlier slide, earlier in the process, we conducted primarily in November, December, some initial research. We launched a survey and conducted over 70 expert interviews, which really continued into 2021 as well. And we also began to develop the preliminary roadmap document itself. We also completed a series of workshops in January and February. Each of the CyManII IFT teams received some excellent feedback from groups of up to about a dozen experts in each of several workshop sessions. And following those workshops, we focused our efforts on updating and refining the roadmap document itself. Again, this preliminary roadmap, and primarily focused on the research routes that I discussed briefly on the previous slide. So all of this work supported the development of the preliminary CyManII roadmap, which was the first year midstream deliverable shared with the Department of Energy at the end of February. One key takeaway here is the importance to this process of being as open and transparent as we possibly can, while also executing a fairly fast-moving plan to continue the updates to the roadmap. And every day our team is working in a cross-functional manner to achieve that important balance. So this is kind of where we've been, and that leads us to the next slide, where I'd just like to mention briefly where we're headed. So one thing I wanted to make sure I highlight on this slide as we look at our planning begun last month after the conclusion of the preliminary roadmap and sharing that with Department of Energy and through the month of June, there are both distinct and ongoing opportunities to engage in the road mapping process. That's one key takeaway here. And over the next 6 to 7 weeks or so, we have several opportunities to engage in this process, and we'll talk more about those, and it's primarily related to the workshops themselves. But just tracing our work again through the course of our roadmap development, starting back in mid-March, this engagement began with the sharing of the preliminary roadmap with members. And again, this was the same document that was provided to the Department of Energy. And a number of sets of feedback from CyManII members has come into us already over the past week. We're greatly appreciative of those efforts. We are actively going through those comments that we received. On the next slide, I'll share just a very brief overview of what we're seeing in those comments based on an initial and fairly preliminary review. The next formal engagement step in this process, sorry, you can stay on the same slide, sorry about that. I'll be careful how I use the word next. The next formal engagement step in the process is a series of workshops, and there will be one for each IFT. Those will be conducted within the first half of May, and I'll share that tentative schedule with you in a moment. Following the conclusion of those workshops, we do hope to have one more opportunity to share an updated draft of the roadmap with CyManII members for your review. That timeline will be tight as we need to wrap up the document to provide it to DOE at the end of June, but that remains our plan. In addition, on this slide, you can also see the parallel RFP process captured at the bottom, just to share it in the context of these ongoing engagement activities, and you'll hear a little bit more about that later in the presentation. So just to recap the key takeaways from this slide, while our road mapping team is actively updating and refining the document itself, these engagement opportunities are absolutely critical to helping us understand how we can improve the document, and particularly from the perspective of stakeholders from industry. So we greatly appreciate your engagement, your inputs, your feedback. We look forward to the opportunity to engage with you both today and in those following workshops. Okay, next slide. Thank you. Again, very briefly, just some key takeaways from some of the comments that we've received thus far. Our analysis is ongoing, and we're working through all those comments on a day-to-day basis. It will take us a little bit more time to get through all of them in detail. But just for reference and to highlight that this feedback is very important to us, here are some key themes that represent inputs, also similar to what we've heard from DOE after their review as well. And some comments include the need to improve the alignment within the document, tightening up language and clarifying some terminology. We know we can also improve the context setting of the document in several areas. I'll also just say that there are elements of this feedback that are very helpful in terms of validating previously known gaps in the work that we've done thus far. And as you've seen from the timeline summaries, this is certainly very fast-paced work. The roadmap will continue to be refined and improved, not only in the coming months, but frankly, in the subsequent budget years as well. So this slide is not meant to be a comprehensive summary of the feedback that we've received, just a snapshot of some of the key themes that we've consistently observed. So again, we appreciate these comments, and we'll be capturing as many of the relevant comments as we possibly can in our work over the next couple of months. Next slide. So the last thing I wanted to share with you is this timeline. Although it says tentative, we're actually fairly, I would say we're getting fairly confirmed in this schedule. So you can note these dates. I'll recap them again later in the slide presentation in today's webinar. But you can see here the series of individual workshops, one for each IFT team, starting on May 3rd with the baselining and CEQ workshop. So we'll continue with the SMA workshop that week, follow with SRDI and TrustWorks, and then conclude the workshop series with CBA on May 18th. So I'll make a couple of comments again as we wrap up the webinar to make sure that you have the right information to follow up so we can get you on the invites for these workshops. And this actually gives me the perfect segue to the baselining team to discuss their IFTs work. So what you'll notice in each of the IFTs presentations, They'll describe some of their key questions or topics of interest, which could form a significant portion of the agenda for the workshops themselves. So I'm going to pass the mic over to Crystal to discuss baselining. I will also check in between each of the IFT transitions, and I'll just ask the IFT leads to ensure that your presentations stick to around the 15-minute mark. I will keep an eye on the clock and just ensure that we're keeping the right pace for those. So Crystal, I'll conclude here. We can go to the next slide. And once you're done, I'll transition this over to SMA. Thank you.
Thank you, Karsten. All right, can we have the baselining presentation?
You can go to the next slide. Yep. Sorry about that.
All right, thank you, appreciate it. All right, everyone, good afternoon. I'm Crystal Castillo. I serve as CyManII's Vice President for Energy Efficiency, and along with Dr. Paulo Costa, Vice President for Securing Automation and Supply Chain Security, we lead the baselining / CEQ, Cyber Security Energy Quantification, IFT. So during the next 15 minutes or so, we will provide you with a synopsis of baselining goals and activities, as well as a high-level overview of our proposed innovation to achieve energy-efficient smart manufacturing and compute the energy ROI that Howard and Gret mentioned before. All right, so let's get started. Next, please. What's baselining? Baselining provides the mechanisms to evaluate and document CyManII's progress towards achieving the big 111 end goals that you heard before. So baselining entails the process of defining the technical metrics and baselinings for other IFTs and also for the upcoming R&D projects. The technical metrics are quite diverse and involve energy productivity, quality, efficiency, cybersecurity, and training, among others, to enable secure, energy-efficient digital manufacturing. So in a nutshell, our job is to keep us on the right track. And we all might agree that if we cannot measure something, we can't manage it and we can't improve it. And that is why baselining proposes a robust quantitative scheme to measure energy realizations enabled by our cybersecurity solutions, which will result in a return on investment for US manufacturers. And this quantitative framework was coined as CEQ, Cybersecurity Energy Quantification, and includes the concept of energy ROI. So this is basically our research component within baselining. Now, elaborating a bit more on the energy ROI, CyManII introduces for the first time a cyber-secure energy ROI. So cybersecurity is commonly seen as an extra cost, as a burden in many companies, right? So we aim to shift this culture to show manufacturers how their investments to protect automated processes and supply chains will pay for itself and give you an energy ROI. Next, please. All right, so baselining contributes to all the end state goals, but it's primarily related to achieving the 1 quad in energy save. If you're not familiar with this unit, the quad unit or quadrillion BTUs is used by DOE in discussing national energy budgets. As you can see in the screen, we got this number by analyzing the energy consumption of each of the 8 sectors. I'm not going to go in details on the computations, but that's how we computed the 1 quad goal. Now, we advocate for using the term intelligent efficiency here, since it is defined as the additional energy efficiency that is possible through cyber tools coupled with industrial IoT devices. And this is exactly our goal here. And intelligent efficiency is also highly correlated with energy productivity. So the $1 million question here is, how can we measure and verify the energy savings produced by a secure smart manufacturing? And for that, the measurement and verification methodologies have been widely used in the past. And the figure at your bottom left shows the evolution of M&B. So we start with M&B, the traditional one, which is a manual meter-based methods, to automated smart meter-based analysis, and that is known as Advanced M&B 2.0, to what we proposed, CEQ. So CEQ advances the current M&B 2.0 capabilities by incorporating cybersecurity aspects. That's probably the most important thing. And by devising novel artificial intelligence, machine learning, and optimization algorithms tailor-made for automated processes and integrated supply chain networks. CEQ will provide a robust methodology for sensor-dense manufacturing environments to allow data fusion and sensor cross-validation with the goal of identifying anomalies. So in summary, we strongly believe that CEQ unleashes smart manufacturing, leading to the one quad in intelligent efficiency. Moving on to the next slide, please. All right, so these are the baselining milestones for the first budget period one. As a fundamental part of the CyManII 2021 baselining plan, we propose the creation of block reports, the first green box on your screen. What's a block? It's a baselining of knowledge, and a block is a peer review manuscript that systematically reviews, evaluates, and synthesizes existing work to locate key concepts and metrics. So we have submitted to DOE 10 of these blocks. We have the foundational ones. One block talks about the energy modeling methods out there, the state-of-the-art techniques to do energy baselining. Another one looks into the cybersecurity ROI and cybersecurity risk analysis methods. And finally, the third one is the one presenting the conceptual framework for CEQ. And then we have specific blocks for each sector, industrial sector. And then we boil down all that information and knowledge to create a cross-sector block. And that cross-sector block analyzes the processes with the highest energy gains, the technology that is being implemented in digital manufacturing, the technology that is still in progress, and we also introduced the methodology, the CEQ methodology, so that we can see how we could compute the energy ROI in a very generic manufacturing facility. And finally, we have another one on supply chains, analyzing digital supply chains and showing the state of the art. Besides that, we also submitted a baselining plan to DOE, and currently we're working on a CI/CD document, continuous improvement, continuous development methodology, to track the progress of all these research efforts. So with the baselining plan and the CI/CD plan, we aim to establish sound methods for measuring and tracking the progress of meeting each of the 111 end goals by using this CEQ framework. All right, next slide. All right, so this is coming from the road mapping document, and these are the research routes for baselining CEQ. I'm not going to go into detail, but I wanted to just give you an idea of our research goals. So the first objective is just to establish the technical CEQ scheme. And by that, we mean the modeling approaches for energy baselining and the methodology to compute energy realizations due to cybersecurity solutions. Then the next goal, it's more about quantification, enabling robust quantification of intelligent efficiency. resilience, and security assessment metrics for both automated processes and supply chains. And these techniques should be very generic, and also should be straightforward, right? So that any non-security experts can use. And then we go into integration, ensuring that the implementation of CEQ enables and encourages a greater integration of device-level assets and facility-level control, and also the interfacing of digital manufacturing applications. If we go to the next slide, please. All right, so the last three research routes, the fourth and fifth are related to our two pillars. One is securing automation, and the other one is securing supply chains. So in here we have a very specific target. For securing automation, we aim to facilitate 15% of energy savings by increasing energy productivity via secure automation and by reducing the carbon footprint. And for supply chain, we aim to facilitate 10% of energy savings by increasing the energy productivity and decreasing the carbon footprint for entire supply chains. And finally, I guess our main widget that we're going to provide, it's enable the increased adoption of open standards-based, open source, secure energy productivity solutions. And these solutions will ensure that we have secure data transfers between industrial IoT devices, and also that we are able to do that cross-validation of sensor readings so that we can increase our productivity and also protect our systems. And these tools, that's why they are open standard-based and open source, because we aim to provide solutions that are good for small and medium manufacturers, as well as OEM and the big boys in the block. So with that, in the baselining plan, we have refined all these research routes, and we have very specific activities under each of those. And that sort of leads to the next slide, our upcoming workshop on baselining. So these are the desired areas of feedback for our IFT. If you decide to join our workshop, we would like to hear more about what is the digital technology readiness in your particular industrial sector. What are the main challenges when implementing and managing energy efficient industrial IoT devices? How your company computes the carbon footprint of supply chains? Do you see current gaps? What would be your ideal tool to compute footprint? And finally, what are the requirements for a new generation open standards-based, open source, secure energy productivity solutions that secure the data transfer among industrial IoT devices? And these questions are just kind of to spark the conversation, but we're going to have, I guess, more discussions and more topics in our next workshop. And with that, I think I'll pass it over to Karsten.
Thanks, Crystal. And I'll just interject myself to pass the baton over to Gabriella Ciocarli to talk about secure manufacturing architecture.
Thank you, Karsten. Thank you, Crystal, as well. Okay, next slide, please. First of all, why do we need a secure manufacturing architecture? I'm going to take you through the journey of our work as a proposal, and also what we are doing now moving forward in actually building a secure manufacturing architecture. But first, we want to understand what did we identify as gaps in existing technology. Next, please. So originally, there have been a lot of models and standards that were more engineering models that they were providing perimeter defense capabilities, control layers, and so forth. Later on, next please, we switched to the industrial IoT concept. If you go next, please. Then we switch to the industrial IoT architecture, industry data, industry-driven data models, and so forth. So the goal of industrial IoT was to collect as much information as possible from systems to assess better the system and to understand their state in a better way. However, both sides are relevant, but what our goal is with the secure manufacturing architecture is to switch from this idea of a network factory where we have all these sensors to actually connected manufacturing enterprise, and then create what we call the secure manufacturing architecture. If we go next, please. And I think you can go to the end of the, yes, thank you. And to create this idea of an intelligent and efficient, secure manufacturing system, where we take into consideration also the cyber and physical layers and apply the fundamentals of physical control loops to processes and apply security capabilities that take into consideration those physical control loop specs. And the goal of SMA is to provide a full supply chain and automation orchestration to secure intelligent efficiency. Like Crystal was talking earlier, right? We want to have this return on investment idea through the energy gains. To be able to do that, we have to collect information on at all the different layers, the cyber, physical, and energy efficiency, and to secure at all those levels. So SMA will encompass a system architecture with composable security and with control engineering, and give us this concept of a secure and smart manufacturing. So like this, we have a full orchestrated supply chain where we have a unified architecture and a validation in our SRDI test beds. Next, please. So what is the overall SMA goal? We want to create an open reference architecture, the SMA, with concepts, methods, and tools that can be instantiated in different manufacturing sectors. Crystal was talking earlier about the different blocks that have been created. Now we have to adapt to all those blocks and come up with all these concepts that will be functional in all the different sectors, and also give us the incentive of creating general methods that can be applied across the sectors. And then we need different granularities to achieve all the epsilon pure properties. And we want to do that in a measurable fashion for both manufacturing automation and the supply chain networks. And first, then, while doing all of this, we want to achieve this energy efficiency that becomes an incentive for security capabilities as well. Next, please. So how exactly do we see the secure manufacturing architecture? Again, the key thing is that we are starting from the physical layer, and we have the cyber layer on top. If you go next, and probably go to the end of the animation. Thank you. Okay, so we have the cyber and physical layers, and we are proposing a common abstraction model. What we are building for SMA is a common abstraction model, both for automation and supply chain. When we were working on the proposal, we realized that the two cannot be detached. They are actually working together as one model, where the nodes are the automation systems in a network, and the network itself is the supply chain that crosses all the different sectors. So the goal is to integrate optimization goals. We want efficiency, we want production, we want to reduce risk. And we are defining an innovation framework really for security, because we are tying all of the idea of automation and supply chain with this concept of a digital identity. We want to capture information throughout the the supply chain that gives us details on the physical layer, what's happening on the cyber layer, what's happening on the energy layer, what's happening. And this passport, so this digital identity we are seeing is as a passport, similar to what the passports do in our lives. We have a passport activity that is validated across the supply chain. We know exactly how the manufacturing process has been lived through the whole life cycle of a product, and we know exactly what happened with the product, the raw material till the end of the manufacturing process. We know what kind of software, what kind of hardware, what kind of energy was used to actually gain that final product. So, and we want to do this by complementing existing standards. And SMA fundamentally wants to build as much formal security validation and agile development in all its functionality. So we are looking in ways in which we can use formal methods for design, for implementation, for configuration, for operation. So imagine that wherever possible, there will be cases where we will not have an immediate use of formal methods, but wherever possible, we want to have clear security properties defined, and we want to integrate formalisms at all the levels, consider also ways in which we can synthesize code based on a secure design, formally defined design, and so forth. And to achieve these high standards, we are also considering continuous integration and continuous deployment. That gives us the ability to always refine our systems, to always know what's happening with our systems, and pretty much have this adequate, agile, and consequential formalism. Next slide. So where are we now with respect to all these goals? So currently we are working on the design document for SMA, both the secure automation and the secure supply chain. We have the different components that we want to consider. We are working on certain demonstrations and prototypes and components that clearly illustrate the benefits of having the formalism included from the beginning of a system, or when we are dealing with legacy systems, how do we integrate the formalism as well? We need to create a vision statement for the road mapping, and we are in the process of creating more and more proof of concepts for the different capabilities that the SMA will contain. So we have a lot of work to do this year and in the following years, and looking forward to working with you and getting your feedback moving forward. Next slide. So let's see what the road mapping captures for the next years. So as Crystal was also mentioning, risk is very important, and being able to quantitatively and qualitatively talk about risk, cost, and return on investment. This is also a research route that we are considering in collaboration with the road mapping and baselining, and of course SRDI teams. Now, once we have all of those will enable us to have better ways in which we can communicate the benefits of SMA. In terms of this idea of a supply chain, we have to build the ledger. So we have the research route that wants to do a secure by design capability for building this ledger, this supply chain, the communication of our supply chain that will enable us to do all sorts of analytics as well, to gain and to understand the benefits of the productivity, risk reduction, and energy consumption. Then another research route is to create tools that are going to be developed with a secure design lifecycle methods. Again, we want to formalize as much as possible all the different capabilities that we have in SMA, and we want to do that also for the vulnerability discovery. And the vulnerability discovery will be targeting both all the different levels: design, implementation, configurations, and operations. Next slide, please. However, even if we are proposing all the different capabilities that are novel and new, we also are very aware that legacy systems can also be still part of the existing manufacturing systems. So we want to complement the secure by design research route with proactive vulnerability discovery and data protection techniques for legacy systems. But again, capturing also legacy systems in a principled fashion, so going hand in hand with our formalisms. And then to be able to collect all this information that the ledger requires, and also the information that will enable us to do all the different assessments of a network and of a supply chain, we are going to build this concept of passport that I was mentioning earlier, the cyber physical identity, which will give us the ability to operate across all the different industry sectors, and will capture information on embodied energy, software, product, equipment provenance, and also everything that we are going to do will be validated in SRDI. The next one, also very connected to the SRDI team, we are building this research route on agility. We want to have this continuous integration and continuous deployment methods and tools that will enable us to assess the SMA capabilities and to validate them. Next, please. And to be able to cope with different requirements in terms of the types of data that are needed in certain industries, or the sensitivity of the data in different industry, or the ability to have environments that are more instrumented than others, we have to have the ability to do the secure automation and the secure supply chain with the different granularity levels, and collect provenance information at the cyber physical and energy levels. So we the idea of a passport, again, the passport will collect all these different information, but it will have different levels of details, different rates at which data can be collected depending on the characteristics of individual secure manufacturers' plans. And then once we do all of this, and once we have all of these components and capabilities in place, we need to also have them used. We want to be able to interact with the community and the industry to actually deploy them in real settings. So and to also transfer all the knowledge that we are building here. So we are going to have the transfer research routes, where we work very closely with the TrustWorks team to transfer all the R&D to education and training materials, so that they can easily be adopted. And on the same topic, we want to have a research route for transition. So establish pathways in which the SMA standards will be integrated with existing standards, or and also develop SMA software development kits that enable an easy adoption. So these are all the different research routes that are pursued. And in terms of the next workshops, we also have a few questions that we would love to start exploring in the following workshop. If you can go to the next slide. Yes, so these are the different questions, and of course there will be more as we open up the workshop. What are the most prevalent manufacturing devices used in your industrial sector? This is very important from our perspective because we want to understand how the different capabilities that we are building will immediately benefit you. What type of data relevant for the supply chain do you already collect in your industrial sector? That is also very important when we are talking about the passport. How do you see the trade-off between legacy and new technology adoption? What requirements do you have for the adoption of the new technology? Again, one very important aspect of all our work is transition and being able to have high adoption. So all of that is going to be very interesting in the workshop. And how do you what do you consider critical assets in your industrial sector? One of the things that SMA aims to protect is the IP. So understanding IP and critical assets. So understanding how exactly you view all these different critical aspects is very beneficial for our capabilities and how to adapt to different settings, given that we have multiple industrial sectors to address. So these are all the different things that I wanted to talk about today, and I'm going to move.
Great.
We are moving to the next topic. Thank you.
Yeah, perfect. Thanks very much, Gabriela. We're doing great on time. Over to Curtis Taylor and Jeff Prevost to discuss the shared R&D infrastructure.
Thanks, Karsten. So this is Jeff Prevost from UTSA, and along with my co-lead for SRDI, Dr. Curtis Taylor from Oak Ridge, we'll be talking to you today about the specifics of the shared research and development infrastructure as part of CyManII, and hopefully ending with some thought-provoking questions that will lead to some more interactions that will help us design the correct infrastructure for CyManII going forward. Next slide. So the mission priorities, as was stated originally by the DoD that CyManII has adopted for the SRDI project, or the IFT, is that our task is to create a federated manufacturing infrastructure hub that's integrated across the entire CyManII ecosystem. So this includes the national labs, this includes the affiliated universities, and this also includes eventually the actual manufacturing systems directly, potentially on actual shop floors. Our task is to support the operation of the other IFTs. This is our main focus in what the SRDI IFT itself is designed to do. We are a provider, so to speak. We will be hosting solutions that are created from the other IFTs, which you heard through Gabriela and Crystal, some of those already. Those solutions are going to be hosted and housed inside the SRDI infrastructure. And one of our primary goals is to be able to offer both physical access to manufacturing equipment as well as virtual or simulated access to manufacturing equipment, and be able to push so we have two different focal points on the CI/CD process. One is to be able to directly update the systems with the most recent information, whether it's a new application or patching an existing application, but it's also to be able to go through new methodologies that are related to the CI/CD process and educate and promote the best practice, so to speak, that we develop in this SRDI research activity set, and offer that to the manufacturing community directly. So one of the things that we want to do is we want to incorporate everything that comes out of the SRDI research activities inside our own ecosystem. So as we build systems and solutions with SRDI, we want to make sure that we're employing best practices from the beginning. So, you know, and in the event where a best practice does not quite seem to completely map our expectations, we develop it. So we're actively researching ways in which we can secure this architecture, provide easy to use access to these solutions, both the physical and the virtual, and to make sure that it enables the other researchers that are part of the ecosystem here at CyManII, all of the other IFTs plus the manufacturers directly, easy to use and seamless, secure access to the artifacts that are created. One of the things that we focus on here is that we want to make sure that the systems that we are creating, both physically and virtually, are able to accurately collect the information related to the energy efficiency operations that Crystal had mentioned, as well as implement the formal methodologies and the formal method verifications that we are creating to ensure security across the breadth of the ecosystem that Gabriela was mentioning. So all of the activities, again, related to the IFTs as part of CyManII we look at our activities as the central support mechanism to enable that. Next slide, please. So high-level takeaway from our earlier workshop, and what we are using now is kind of a guidepost to make sure that when we think about what we're building and we think about how it's affecting the community, the ecosystem at large, we want to make sure that all of the people, the original people that are involved in this particular IFT, as well as all of the newcomers that onboard and become part of our activities, understand at the very highest level that the overall methodology or the overall principle that we want to hold dear is that we are secure by design, in that from the very beginning, we do not test or vet partially secure solutions. We want to make sure that even at the very earliest of a prototype, that we are thinking about how does security interlace into the process that we're trying to enable. This is first and foremost in our minds at all times. And so even our very simple hello world style proof of concepts that we build, they start with the premise of they will be secure. They will not simply take the easy way out. We are making sure that that is baked into everything that we do. But the complementary issue that we are holding dear is that the systems and the solutions that we create need to be easy to use. And so if the solutions that are proposed from the infrastructure procurement, deployment, and maintenance perspective are not understandable, that are not accessible, that are not relevant to the community at large, whether the community is the research community or the manufacturing community directly, they need to have interfaces that we provide that can be accessed with minimal effort, where we can show examples and provide those testing architectures that have already been vetted, that someone can come in and get into to learn what it is that we have promoted, and then recreate and extend it according to their own research needs. So the interfaces need to be easy to use, they need to be secure, and we also need to make sure that from the very beginning that we start off with best practice. So we think of ourselves as being evolutionary, that what we are intending to do is to capture and promote all of the best practice architectural solutions that exist in the software development world right now. But that's not where we stop. That's where we start. And so we are looking to develop and enable technology solutions around the delivery, the maintenance, the hosting of these solutions in ways that are novel as well. So what we really intend to do is, as an example, we want to develop new CI/CD tools, the continuous integration and continuous deployment tools that can help enable manufacturers update and keep their systems with the very best information and algorithms that are out there in ways that are provably secure. We also are very keen on making sure that all of the different artifacts that are created inside the SRDI ecosystem, so anything that either goes to the build out of our ecosystem or the extension of our ecosystem down into different manufacturing entities follow a principle of reproducible research. So we want to, as an example, script everything that we deploy. So if we do a build out for hardware, for the infrastructure itself that enables the algorithms and software to do what they need to do, that initial build and deployment is done in a scripted process. So it's not simply a one-of design that somebody gets into and iterates and then may or may not be able to reproduce exactly in the future. So everything that we do is based upon that principle of a reproducible research design practice. And we believe that it's going to allow us to create a legacy of these impactful artifacts from here going forward that are actually implementable by both the research and the manufacturing community. And as I had indicated initially, the solutions that we create from SRDI, they really need to be viewed with the lens of being relevant, usable, and trusted by specifically the manufacturing community. So we don't want to create solutions that are so difficult to implement that they really will never see the light of day in an actual manufacturing setting. What we want to do is to create something that's truly impactful. And so as we think about how you go and deploy those complex baselining and the SMA solutions and even the CVA solutions that you'll hear next, we want to make sure that as we do our part to being able to get this all the way down in and out of the manufacturing community directly, that we do that in a way that is doable, that is usable, and is trusted by the manufacturing community directly. Next slide, please. So over the course of our research so far, which arguably has not been very long, it's spanned the course of a few months so far, but we've already come up with a fair number of questions, and this particular audience seems as if this would be a great opportunity to engage some of these questions. And these are the general things that we keep bouncing back and forth between ourselves from the SRDI team itself. Questions such as, is there a standard network architecture that is in use by manufacturers? Does this exist? How varied are the actual implementations once you get all the way down into a specific implementation, from the small manufacturers all the way to the large manufacturers? How are the machines themselves connected typically on the manufacturing floor? So of course, we're talking about machines that can be networked. I mean, if you have legacy manufacturing equipment that is not networked together, then we have to think of different ways to be able to censor that machine and acquire the information necessary to be able to capture the energy footprint and the security footprint of its operation. So some of these may not be completely applicable in all cases, but what we want to try to do is we want to try to reach into the collective knowledge of the people that deal with the manufacturing sector and find out what patterns exist that we can encode. So we would like to be as relevant to as large a group or as footprint as possible, and to affect as large an actual manufacturing output as we can from the beginning. So we, of course, would like to focus on those network architectural use cases that seem to capture the broader audiences. Not to limit to that, but simply to start with that as a starting point for our designs. Do manufacturers manage their own network security? So is this a common practice? Do manufacturers have people that have been designated inside their facility that have been tasked with the process of owning network security? Or is it typical that they contract this out to third parties? So the people that actually work with the manufacturing community to consult on actual workflow optimization, on the machining itself, or in this case, in the network security practices, those would be potential people that we would like to interface with. We'd like to learn more about what they do and learn ways in which we can engage with them to help facilitate what they do, and take those lessons into the processes that we're developing with SRDI itself. Again, what we want to do is to make sure that we are as relevant as possible with the manufacturing community. And to do so, I think it's critical that we partner with the people that the manufacturing community currently partners with. And so another question that kind of drives the entire premise of how is it that you can apply advanced algorithms to help optimize the processes of manufacturing? It implies this aspect of network connectivity back out to the internet itself. And so what level of cloud connectivity typically is seen on the manufacturing floor itself? How do updates occur? So is it a automated process, sort of a Windows update that's set to auto mode that just continually gets new patches of software that make sure the manufacturing equipment and or the supporting machines themselves that help run that manufacturing operation are kept up to date? Or is that a manual process? Is that something that people do periodically and very specifically after going through a vetting process to make sure that the actual patches and the software updates that are being applied have been tested and that have been deemed necessary and secure? So if the cloud is used, what is it typically used for? So if the cloud itself, if cloud computing topologies are used in the manufacturing sector, what is their typical use case? Are they used to access manufacturers' repositories for those patches and those updates? Is that what the primary use is? Or is it used to store designs or to store other information that is relevant to the manufacturing operations itself? Are there currently analytics that are being used by manufacturers that are cloud hosted? So are there cloud service layers that are being accessed, or are there cloud infrastructure layers that are being accessed? And if the answer to the first question is no, that typically no cloud is used, then why is it not used currently? Or better way to frame it is, what is the reason for that? Is it simply we've never seen a compelling reason, a compelling benefit to be able to connect or to go through the process of interconnecting our systems to the cloud? Or we have very specifically not connected our systems into the cloud, created that very clear air gap between the manufacturing network and the external networks of the public internet for fear, for the fear of being hacked or attacked or having ransomware placed on systems that render the manufacturing process unworkable. So what are those motivations? And I think for us, understanding those motivations are going to help us understand what the story is we need to frame when we speak to the manufacturers directly, and how we can enable the systems to be secure and easy to use. And lastly, was any change in the manufacturing process made specifically due to COVID? So remote access is an example. How do we get remote access in and out of the manufacturing center in this pandemic area? Were there relaxations? Were there VPNs that were created for that? What are those protocols that people did specifically for an environment such as we find ourselves today? Next slide. I think that's it for SRDI. So thank you very much for letting me present the SRDI issue set to you, and I pass it back to Karsten.
Perfect. Thanks very much, Jeff. Again, we're doing perfectly on track for time. Thanks to everybody so far. We'll now pass it over to David Nickel to discuss coordinated vulnerability awareness.
Hi, thank you very much, President, to be here. So the role that we play at CVA is to focus on vulnerabilities, making the small and medium-sized manufacturers aware of them, of their impact, help them in dealing with their occurrence. We are also involved in defining processes for disclosing vulnerabilities. Now, to do this, we don't just make it up all by ourselves. There's a lot of activity that's going on in vulnerability disclosure already in DOE and DHS and other places, and we need to mesh with that. We don't compete with them. We use that where at all possible. So we have to align with whatever those efforts are. And we know, since we are a DOE effort, that there are particular requirements that impact the discovery of vulnerabilities when they are on DOE campuses using DOE resources, and that puts us down a whole other track. But the point is that we need to understand what those are. We need also to understand what manufacturers have as far as constraints that they might have or expectations that they have in learning about vulnerabilities and ways of dealing with those. So all in all, we were coming to this. There's processes in place already. There are entities that are engaged in those processes, and we need to define a proper role for us in there. One of the challenges CyManII has are the numbers that Greg showed about savings, about training, and for us in particular, the number of so-called vulnerability instances that are avoided by dint of using CyManII technology. Well, so where do these numbers come from? One has to have some sort of mathematically based, mathematically sound methodology for estimating the impact of the reduction in these vulnerability instances if you take certain steps. So there's lots of different kinds of steps one would take. And so coming up with some way of approach of describing this, of estimating this, serves to help defend that CyManII's meeting its goals, but more importantly, it serves to communicate to entities that need to be aware of vulnerabilities, need to take action on vulnerabilities, need to take actions to avoid the possibilities of vulnerabilities, what the impact of that is, and ultimately one uses this as a basis for connecting to ROI. At the end of the day, one puts dollar figures on the investment in avoiding these vulnerabilities, but to get to that point, you need to have to connect the dots between, if you do this, this is going to be the reduction, and so that's part of our tasks there. We need to develop what we'll call an awareness framework. What that means, or some of the things that means, is we need a precise language to describe kinds of vulnerabilities, the relationship between them, speak precisely about how different actions one might take reduces these kinds of vulnerabilities. It's more complicated than one thinks at the face of it, and there are dialogues going on even as we speak to come up with such language, such taxonomies. But the net result of that is when you have a precise language, then you can be precise about policies, you can be precise about doing analysis, say formal methods of privacy, or whatever it happens to be. You need precision in describing what this is. And so we're working on that as well. And then another aspect of awareness is training materials. Again, we're going to be reaching out to small and medium-sized manufacturers. Maybe they don't do very much in the way of dealing with vulnerabilities as they are disclosed. And our job is to not only train them of the need to do this, but where we can train them how to do this or how to get it done. Next slide, please. So the key themes that come out of the research routes that we have developed through a series of workshops and interactions with stakeholders is one, I just spoke to this at some length, is to develop tools and techniques to estimate the reduction of vulnerability instances induced by application. Related is with CyManII or anyone is going to be trading off the amount of effort that they sink into doing a vulnerability disclosure, or more probably precisely remediation, and the payoff of that, the reduction of the vulnerability instances. So this harkens to the precision as well. We need some precision to speak of and think about and reason about the process of going from a hint of a vulnerability to a disclosed vulnerability with recommended mediation. Training, I mentioned that before, that's obvious that we need to do that, and we are already engaged in that. Looking at the process that goes on with vulnerability disclosure, again, going from the first report of it to some disclosure with eventual remediation, looking at that process and identifying where there are bottlenecks and how these bottlenecks can be alleviated or those steps can be accelerated to make the remediation available faster than it is now, is a part of what it is that we need to be doing in this effort. Next slide, please. So one of the things that is clear to us, particularly to me, as I didn't have a background in manufacturing before coming to this, is what are the specifics? What are the differentiators in smart manufacturing that we need to focus on to help us develop strategies for prioritizing the resources that we do in treatments of vulnerabilities? So the larger picture, I didn't say the first bit quite as well as I would like. So in the cybersecurity space, even the cybersecurity in industrial control systems space, there are a lot of players and a lot of work and a lot of effort and a lot of processes. And that's all good. We want to leverage that. We can't and should not try to replicate that. We need to know what it is, and we need to take advantage of that. But it has always been the case, I believe, in my decades in working in things related to cybersecurity, that you come to a domain and there are differentiators in that domain that emphasize certain kinds of problems more than others, that offer techniques that are more readable to be used than others, or techniques that this just won't work in that context. So what we really need to do is to understand this intersection of cybersecurity, how it's viewed, how it's treated in manufacturing, so that we can do what it is that we do in a formed way. And so, for example, one thing that, not being a manufacturing person at all, kinds of things that come to my mind is, so what functions are there automated that if there was some sort of interference so that the process didn't work anymore, that lead to major consequences, and at a time scale that's faster than human detection or reaction. So the point that I'm trying to make here is that places where automation is going to be needed are places where things happen so fast that humans aren't going to be able to react to them. So in both of these bullets here, that's what we're trying to get at, is there are automated processes, maybe they are impeded, maybe they're maliciously manipulated. The impact of that happens faster than a human can be. So where are those? Because those are high consequences things. We need to be really looking for vulnerabilities in those kinds of process. The development of systems that have vulnerabilities in them are going to be done through OEMs. And so they have already processes in place, expectations in place, requirements in place for how they engage in reports of vulnerabilities in their things. And so we need to understand what those are. So we desire dialogue with such folks to come to that kind of understanding. And we're also, going back to this core activity of vulnerability disclosure, want to talk to people who are already experienced in this and come to an understanding of the specialness, if you will, of manufacturing, and have them tell us what challenges they see for CyManII. in developing approaches that are needed. They're not just replicates of something else. They're actually needed for manufacturing and are potentially impactful. And that, I am pretty certain, is the last slide.
Great. Thanks very much, David. Appreciate that presentation. And to shift over here, we'll go to the last IFT presentation. This is Paris Stringfellow to discuss TrustWorks as a service.
Okay, thanks, Karsten. Hi, I'm Paris Stringfellow. I serve as the Vice President for TrustWorks as a Service, which is the sustainability mechanism for the Institute that is going to provide revenue for the Institute's operations beyond year 5 and sustain the continued R&D. Next slide, please. Okay, so what is TrustWorks? TrustWorks is a service-based entity where fees will be charged for services around education and workforce development, applied research, and then technical support for companies as they're working to migrate toward secure and energy efficient operations. And so we call those services TrustWorks EDU, TrustWorks Science, and TrustWorks Secure. So TrustWorks is going to provide the mechanisms to share the innovations that come out of the other IFTs, and it's ultimately going to help us achieve our 111 goals. Okay, so why is TrustWorks important to our vision? So as I mentioned, TrustWorks is the sustainability plan for the Institute that's going to provide the revenue to support our R&D beyond year 5. And so the idea is that we're going to do this by enabling manufacturers with the tools and techniques and solutions that are going to emerge from the IFTs like SMA and CVA and baselining and SRDI. So it effectively acts as this conduit to help get the CyManII solutions into the hands of the manufacturers, and it's going to provide them the support they need in order to implement these solutions. So again, the whole idea with this concept is to make sure that the products that come out of the Institute are relevant and usable to the manufacturing community. So we want TrustWorks to help bridge the gaps that are currently preventing manufacturers from adopting and from implementing these cybersecure and any energy efficient solutions right now. Next slide, please. So one of the key goals that of TrustWorks is to educate and to train 1 million workers in cybersecurity and energy efficiency by year 5. So yeah, big number and big goal. So this slide shows some of the original assumptions that we had and how we hope to reach these workers. So you can see that there are almost 5 million employees in the 8 energy intensive sectors that are within our focus. And so we're assuming varying degrees of market penetration for each sector, ranging from 3% to 15%. These are the same levels of market penetration that Crystal Costello shared with you earlier. So if we can reach each of these levels of market penetration, then we can estimate that we'll be able to reach over 400,000 workers in these sectors. And again, that's the incumbent workforce, the current workforce. But we recognize that we can't just upskill the current workforce. In order to protect tomorrow's manufacturing systems, we're going to have to educate the next generation of manufacturing workers. So we assume that we'll need to reach another 500,000 learners within the universities and technical colleges. Okay, next slide, please. So this year, we really focused on standing up the Institute and establishing the foundation for the TrustWorks as a service organization. So our first steps were to establish TrustWorks operations, which you can see in 6.1. And so this involved establishing advisory boards for both TrustWorks itself, but also for the education and workforce development activities. So our initial set of board members have been identified, and now we're just working on establishing operational guidelines by developing the articles of organization. So we're also working on an outreach plan that's going to detail how we're going to reach the stakeholders that are in our target markets. And then we're going to conclude by submitting a vision statement for year 2. In order to share or disseminate the educational content that we developed or will develop, we're going to have a functioning website and a learning management system to deploy this. And so we plan to have these websites completed by the end of the year. And then lastly, we plan to develop an education and workforce development plan to inform the activities in year 2. So we're currently piloting this with a Scrum team we call the Transformers, where we're working to develop educational content and experiences around vulnerability advisories. Okay, next slide, please. So now, as Karsten talked about, we've been working to develop this strategic roadmap, right, for each of the IFTs. And it's been lots of discussion and lots of interaction with Institute stakeholders. So these discussions produced 7 different research routes for TrustWorks. Now, in the context of TrustWorks, I like to think about research routes as objectives of what needs to be done in order to establish a fully realized organization that's capable of translating Institute innovations to the manufacturers, and that's also capable of sustaining the Institute long-term. So the first research routes really focus on addressing how TrustWorks needs to operate. So the first route here, it deals with establishing the infrastructure that we need to set up in order to provide regular support. So this could include, developing business models or maybe standing up staffing and resources that we need to operate this organization. Okay, we also need to have appropriate measurements so that we can ensure continuous improvement of our services and improve the continuous improvement of the educational impacts. So as Crystal mentioned, we can't improve what we don't measure. So next slide. Okay, the next couple of research routes focus on establishing what I call the value propositions to the companies and to workers for that matter. So they really address what it is that we at TrustWorks will provide. So one of our first challenges is to address an underlying issue, which is the current business culture around cybersecurity and energy efficiency. So the foundational research route at the top here, it aims to improve the culture so that manufacturers can place a higher value on secure efficiency. Okay, so this might involve addressing the ROI of cybersecurity, for example. Okay, the next route is really a major focus of the Institute. You've heard me talk about it already, and it deals with developing and providing the educational training material and experiences for workers and learners in this space. The third research route deals with developing tools and technologies and methods, all based on the activities and findings from the other IFTs. Okay, so here in this research route, for example, we might look at developing a tool for maybe assessing and monitoring operational risk and maybe associated energy savings on an intelligent manufacturing system. Okay, or maybe we provide stakeholders access to the systems and CI/CD solutions within SRDI that Jeff was mentioning earlier. Okay, next slide. So if the other research routes focused on how we need to operate and what we need to provide, these last two routes, they really focus on how we need to reach our target markets. So we know that information sharing is going to be a big part of our ability to just move the needle in this area. So we need to find the best ways, the most effective ways to communicate and to disseminate this technical concepts and the findings to our industrial audiences. Okay, and the second one here, we also need to develop the networks that are going to be so important for reaching our audiences. So, in this research route, it might include, developing a hub and spoke relationship between member universities and maybe their regional community colleges. Or maybe it might involve establishing working relationships with some of the professional organizations that are specific to each sector. Okay, next slide. So maybe you have some thoughts on the research routes I just shared with you. And if you do, we'd love your feedback and input. If you decide to join our workshops, we would love to hear your thoughts on, how should we go about measuring progress and impact within the TrustWorks IFT? Okay, and what are the driving metrics for different audiences? For example, what's important to a small manufacturer, it may not be as important to the IT/OT integrator or maybe to the educational provider. We'd love to hear from you as to what typically prevents companies from adopting tools and technologies and methods. Okay, so in large companies, in large companies, is this different? Or in small companies, is this different? Or among the suppliers and integrators, or even the device manufacturers, is this different? Or the inverse of this question might also be, what motivates or incentivizes these different types of stakeholders to adopt and implement security-related tools? Okay, we're also interested in what types of dissemination would best resonate with some of these audiences. And then, of course,
I think we lost
So from my
Paris's
end,
network connection, Kirsten.
yep,
Yeah.
looks like, and I think Paris was just wrapping up, so we'll take that as a natural transition point. Paris, thanks very much. We'll keep moving. I think you were at the conclusion of your remarks, and I've got a slide. If you go back to the one prior, Doug, just for a moment, before I hand the baton over to Wayne for a few comments on the RFP process, I just wanted to share another quick summary of the workshop schedule on this slide here. And we'll be doing a lot more outreach for these workshops over the coming weeks. So I just wanted to say that if you have any specific interest in attending an IFT workshop, please contact me. You can also email the IFT leads if desired. They'll pass that information on to me, and I'll make sure that you're included in the invitations, which will follow in the coming weeks. But these dates and the 2 to 4:30 p.m. Eastern time slot is pretty well set for these workshops in the first half of May. And you can certainly attend more than one workshop if desired. We'd love to have your participation. So tomorrow or the day after, we will send a follow-up note to this full group that will also include my email and a little bit more context on the workshops. Again, the approach, agenda. You heard many of the types of questions that we hope to address during those workshops. We'll also be reaching out to attendees to sort of poll you for some of the topics that you're interested in learning more about or hearing a little bit more about as well. So again, there'll be plenty of opportunities for us to engage with you to set up your participation. We encourage your participation in one or multiple sessions where your interest and expertise lies, specifically those of you from the manufacturing industry. We're very, very eager to to get your detailed perspectives on the work of each IFT. And with that, I will pass the mic over to Wayne to discuss the RFP process.
Thank you, Karsten. So Wayne Osted, I'm the Chief Research and Development Officer for CyManII. I'm homed at the Idaho National Laboratory. Just about 3 slides describing the upcoming and first RFP process. Next slide. So just as a reminder, this was Karsten's slide about the timing associated with our roadmap. About the time that we drafted, just shortly after the first draft of a preliminary roadmap to share with the Department of Energy. There was also an initial draft of a small RFP to go out this first year. A lot of the activities with the Institute on the first year has to do with stand up and developing the roadmap itself, but we also wanted to exercise the RFP process early and get folks engaged on some of the early research challenges that we knew were going to be priorities based on the preliminary roadmap. So pending DOE approval, we expect the RFP to be released in early May and approximately 30 days from that. So early June would be the proposal due date. Next slide. So the timeline, how these RFPs should work year to year is that approximately 8 weeks after the RFP release is what we're targeting for notification of selection. What we have is in the middle of that, we would be asking for the proposals to be due based on that RFP. And then approximately 9 to 10 weeks after the selection to work through the DOE awards and contractings. Now note, this is the first time that CyManII has gone through this process with the Department of Energy. This is a accelerated process compared to some institute processes. We think it's very realistic and also very necessary relative to the innovations that we seek. Next slide. So a little bit of orientation on the approach and what you should expect from the focus. In general, any member of CyManII can submit a proposal, but in order to be awarded, you need to be at the collaborative membership or higher, and it is easy to change membership levels. That's required in order to attach funds to your institute with the appropriate vetting, as well as to establish the credentials into the CyManII ecosystem. Of course, the challenges in the RFPs, both this one and future, will be aligned to the challenges that we identify in the roadmap and the priorities that we need to establish either by timing sequencing or by state of the infrastructure in the institute or by state of the ongoing research. You should note that a lot of the proposals and solutions need to have an orientation towards using the CyManII ecosystem. And what I mean by that is there's a lot of work that's going into creating the shared research and development infrastructure, creating the continuous integration and continuous deployment build chain as formal methods are advanced and integrated into that formal testing build chain in the CI/CD process. Those tools will be utilized and useful for individual innovation developers. And so really this is a case of the sum of the whole is greater than the parts, and this ecosystem is going to become invaluable to validating individual innovations, but also accelerating the deployment and integration with other activities that are going on. To do that, you really have to use and be credentialed into the assets that are being built up in CyManII. And with that, you're going to see over time, as these tool sets build, as the formalisms build, as the ecosystem matures, as the deployment mechanisms and outreach with TrustWorks and the portals get set up, you're really going to find that this is going to be an amplifier for the individual work that you have and the mechanism in order to build the shared R&D resources that you may have in your own individual laboratories or your companies that can accelerate other people's innovations to be adopted into your particular assets and innovations. For this first budget period, there is going to be a much more limited call than future years based on the significant resources and time that we've had to spend standing up the institute, standing up the initial environments, as well as developing the roadmap. But when you get into future years, we should get into a broader set and more mature set of research route activities And as the ecosystem develops, hopefully this will provide an acceleration and formalism to vetting secure by design and vetting the validity of your innovations as we're deploying them across the ecosystem and across our industry partners. Again, we're still in review with DOE before this RFP is released, but I can't emphasize enough that the RFP in your proposals, you should be thinking about the foundational task alignments, because that's how our research routes are organized so that we have a consistent ecosystem going forward. The priorities will be established in the specific activities over time as we evolve this living roadmap. And the innovations are going to be developed inside this ecosystem that everyone can benefit from, and your individual innovations can benefit from the work of others. That's pretty much all I wanted to cover on this. I'll yield the rest of my time to, I believe, Howard and Tom, who have some exciting discussions.
Thanks, Wayne. And thank you, everyone, for the time you've invested, on this with us. We really look forward to further engagement, as we drive towards the final version of the roadmap, at least for this year. I know Paris cut out at the end, so I just wanted to point out one thing. In starting in September of this year, we will be doing a more focused roadmap on the TrustWorks sustainability model to make sure that we really get that right for both the workforce development piece, but also the TrustWorks Science and TrustWorks Secure as a service. So with that, I am ceding my closing comments to our Chief Manufacturing Officer, Tom Kerfus. So Tom, turn your camera on and your microphone and take us away.
Great, thank you, Howard. I just have really one slide that I want to bring up, so we can go to the next slide. Thanks, Doug. Great. So basically, a couple of things here. So you're going to see over on the right, this is a 3-robot additive manufacturing system over here at the manufacturing demonstration facility at Oak Ridge National Laboratory. So again, one of the key things is we really do have heavy-duty capabilities in terms of next generation manufacturing technology, where we are doing a lot of cybersecurity type of work on industrial grade systems. So this is not just, hey, we're doing theory and so forth. This is really where the rubber meets the road. And it's critical. And I do a lot of discussions on the whole digital thread and manufacturing and so forth. And it really is it's a two-way street. Clearly, we're getting a lot of data from our systems that are out there in production. And that is feeding a lot of our next generation models, machine learning, artificial intelligence, and so forth. And we want to make sure that those data are protected. The same thing in terms of the other way around, some of the things that Paris was talking about. What about workforce development? So how do we make sure our workforce is using the latest and greatest capabilities in digital manufacturing at their fingertips, but doing it in a secure fashion and making sure that our plants are secure? Really, one of our mantras here at Oak Ridge is innovating faster than the competition can copy. Yes, they're going to copy us, but we're going to innovate faster. That being said, if you do have proper cybersecurity, it is going to be much harder, as you've already heard, for that innovation to get a hold of the IP. The digital thread allows us to do a lot of learning from production. It allows us to integrate design and manufacturing, but it also allows us to really make use of our human capital, and that's really what we're all about. I think everybody is familiar with sort of cloud and edge and fog, where the edge touches the cloud, and we've got compute, communicate, and storage. So everything is really happening today out there that is going to leverage digital. We have got to weave in the cybersecurity, and that's the real critical point here. Cybersecurity must be woven in. It's not just an add-on at the end, or let's put up a wall. I think we've heard about that. It's got to be part of the culture. 30% of all cyber attacks against manufacturing operations, and the bulk of those attacks are to try and secure intellectual property. We have to protect that property, that intellectual property, or in fact, we're taking it to the next level, even on classified information. But to me, really the most important thing is that digital thread allows us to engage what we would call the small, medium-sized enterprise. These are the backbones, the mom and pop shops that make up the backbone, 85, 90% of the entire US manufacturing ecosystem. These individuals need to be brought along. So it's great if you're a very large manufacturer, an OEM or a prime, but the bottom line is you also need to make sure that your entire supply chain, your entire ecosystem is digitally secure. And that is just incredibly necessary. And so I'd like to close, and I'll turn it back over to Howard with a quote from one of my favorite philosophers from the 20th century, and that is, in times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists. Like when Eric Hoffer wrote this back in the 20th century, it was correct. Today, it's even more important because that rate of change is accelerating. Information flow and technology is accelerating. It's becoming critical. We need to make sure that we protect it, not just by throwing up a wall, but by having a culture of cybersecurity. And that's really what CyManII is all about. It is going to really allow us to innovate faster than the competition can copy. Thanks very much. Let me turn it back over to Howard.
Thank you, Tom. Fantastic way to end. You know, I started off by saying we had two major objectives for this webinar. You know, the first one was to inform you at a high level of detail the status of the national roadmap for cybersecurity in U.S. manufacturing. And the second goal is really to, you know, encourage your participation in the upcoming workshops that, you know, that Carson has already mentioned. So with that, Carson, I'm going to turn it over to you to wrap us up and to take us through Q&A.
Great. Thank you very much, Howard. Thanks for everybody for the presentations today and all the work going into the prep for this this webinar. First, actually, just a quick thanks to one of our attendees. I have already received my first workshop attendance request, which is great. Again, we will share my contact info to this full group via email. I'll also put it in the chat here before we break to facilitate your email to me with the IFT workshops that you're interested in attending per Howard's comment. So what we'll do now is we'll, again, shift to the completely optional Q&A session. I believe most of us from the CyManII team will stay on for this period. And this is meant to be your opportunity to address any questions that you'd like to with the group of leadership and IFT leads. If you use the chat function to provide those questions, we will go through. We've already got a list of about 4 or 5 questions that we can start with. But please add any other questions to the chat. We'll go through them one by one. I think we'll certainly have time if we use the full 30 minutes to cover any questions that come up from the group. So if that's okay as a sort of transition and shift to that focus, I will start with a couple questions that we've received. I will work with my CyManII colleagues to complete any answers that I may not be able to fully answer by myself, and we'll get through each of these. So the first question that I see to kick this off, are we in need of additional workshop participants from industry across the board, or do we feel like we have enough already to get the desired feedback from each IFT? I'll add my response. I'm sure others in the team will echo this. I'll just say that in terms of workshop participation from industry, we are very eager to get as extensive as possible participation from the manufacturing industry. So we definitely need more teamwork, more participation, and we look forward to getting that as much as we can in those workshops. Howard, did you have anything to add to that?
Yeah, I want to emphasize once again, you know, the Institute will simply not be successful if we are not elbow to elbow with industry advisors, engineers. Everything, you know, must be guided by industry. You know, the Institute is mandated by the Department of Energy to work at TRL levels 2 through 6. If you don't know that lingo, it's technology readiness level. TRL 6 is, well, TRL 9 and 10 is commercialization. So we are not in the business to produce products, but what we do need to do is work with industry to produce technologies and innovations that are relevant to industry so that we can hand those technologies and innovations off for further refinement and commercialization and entry into the marketplace. We are adamantly interested in securing industry engagement, not only in the workshops that are coming up, but in all of our activities as we move forward. If we're not developing industry relevant technologies and innovations, then quite simply we miss the boat. So absolutely, we will work with our universities, with our labs, and with our companies to continue to grow our private sector engagement.
Yeah, I just want to add, Karsten, that I look forward to the day when industry participants outnumber the lab and academic participants on the technical team side. It's a day I'm really looking forward to. Thanks.
Thanks to you both for adding that. Okay, I'll keep us moving here. And if Curtis, if you're still on, I think this question may have been one that you acknowledged in the chat earlier. And the question is, given the topics discussed, what are the expected data collection practices? Is that one that you were planning to address?
Yeah, so that's I guess that question could be interpreted a few different ways. But I think what I'll say is, one of our research routes is related to reproducible research. So that's kind of a focus for us, is how do we support as innovations come in? How do we continue to support allowing other people to reproduce that research? And the data collection process is going to be important to that. So I'll say that we're not trying to throw out a solution right now. I think that's a great opportunity, in the RFP process, maybe if that happens to be able to fit its way into the scope, to think about, how do we, for example, consider a common data model across all of our different experiments to really be able to leverage, data in as many ways as possible. So there's the data from the infrastructure we're running, from the experiments. There's that aspect of data, but then there's also data of SRDI from a security standpoint. So ensuring that we're monitoring, what's happening between our CI/CD pipelines, different containerizations and software that are running, right? Because we're trying to do actual vulnerability testing, right? So we need to watch not only ourselves, but we need to watch the research. So there's a data collection aspect is there, there as well. So hopefully that answers the question. Just kind of shortly put, yes, the data collection aspect is important. We're not trying to say we have it solved at the moment, but it is one of those things I'm looking forward as SRDI continues to grow and evolve. I think that'll be one of the more interesting aspects of what SRDI offers.
Thanks very much, Curtis. Anybody else from the CyManII team, anything to add to that? And we see a response. Looks like that was helpful. That's great. I'll keep going down a list of some of these questions. Next one I have here is, will the workshops be recorded for members that cannot attend? That is absolutely the plan. I think it's worth making the point that we will need to be careful about the sharing of information. Some of these elements will be shareable to CyManII members only, although the inclusion in the workshop events themselves will not be exclusive to CyManII members only, but some elements will be. So, but the plan absolutely will be to record those events. Next question on the list here: can CyManII provide a summary document, 1 to 2 pages, that includes all the questions that each IFT has asked today in the upcoming workshops? Absolutely. We'll provide again a follow-up email in the next couple of days with some additional information. We can include within that email a summary of those IFT questions. And again, I would frame those as specific to the IFTs at the moment and representative. It's not meant to be a specifically prescriptive, that those are the precise questions that we'll plan to discuss in those workshops, but I think the goal will be to discuss as many of those as we can. We will also want to balance that with ensuring that we're hearing from workshop participants, and so we'll do a little bit of a survey mechanism to gauge from planned attendees some topics and questions that you're interested in as well. So we'll balance that in those workshops, and I'm sure there'll be significant overlap as well. I'll keep looking down the list.
Carson, I want to address a question from Tommy Gardner from HP.
Absolutely.
It's because it certainly is to Jeff and Curtis, but I wanted to preface it with a few thoughts. So it's about the containerization and NIST 800-204 concerning microsegmentation and virtualization. You know, there's a lot of good work going in there that kind of ties into the zero trust architecture work that's going on out there. Part of what we want to be able to contribute is efficient assurance that a aspect of a zero trust architecture is being correctly implemented. And this kind of comes back to the formalization and structured analysis that Jeff was talking about, and as well as Gabriella. You know, it's one thing to say we are going to comply with a given standard. It's another thing to have high confidence that you've applied the standard in a way that's going to be effective at providing the security property that deters your adversary. So with that, Jeff or Curtis, I don't know if you wanted to add to the NIST comment in particular.
Yeah, so there were three comments total I see from Tommy, and I appreciate all these. So, you know, come on in, the water's fine. You know, I want to talk about this stuff. So we've spent a little bit of time already on speaking to zero trust. So we have a technical architecture that we're diagramming for an ongoing Scrum effort we call Project Sunshine, that is trying to get a quick instantiation of a lot of the core aspects of SRDI and some of the formal methods aspects of SMA. And we have, in that diagram, we have overlaid the zero trust architecture and where the policy enforcement points and the policy decision managers, where those things exist in our infrastructure, both from a user perspective and on the OT side. So we are actively tracking that, and it's the zero trust architecture documents a little less, it's a little more open to interpretation on some aspects. It's not a hardened, you know exactly what to do. So we're trying to fit into those models as best we can. And I think when it comes to the microservices, I don't think we're explicitly going after the NIST side of things, but we are microing everything. So it's all microservices, whether in the cloud or on hardware at the plant. Everything is running in its own container. It's, you know, least privilege, deny by default is the approach. So we're trying to maintain all of those things, but to Greg's point, you know, it comes back to it. At some point, we want to take that a step further in linking up with SMA and taking some of those things. We want to be able to prove, you know, aspects about what we're saying, you know, we do, right? You can say we're zero trust, we have microarchitectures, look at our document, right? But at the end of the day, you want to monitor that and you want to prove properties about it in the future. And I think that's that more novel next step that we're trying to take. We're in the process of doing the implementation right now, but we want to get to that next level eventually. So I'd love to continue these conversations. And the point about CIA, yeah, availability is absolutely the big one, and there's not as much focus on confidentiality and integrity. And we're seeing that now in some of the protocols that we're attempting to secure from the factory floor to the cloud. We're coming up with clever means, I would say, to try to protect protocols that currently don't have confidentiality or integrity even in the standard, but are important to manufacturing. And so that's another opportunity we see as an engagement to work with industry to start furthering the ball on some of those, so that they may not think confidentiality is important, but hey, let us tell you the reasons why and work with us as to how to improve that standard or that protocol.
So yeah, let me just also further reflect upon the question and kind of provide a little bit more backing for what Curtis was just mentioning. The practices such as the NIST recommendations that are put out in this document and other documents are things that the SRDI team itself has looked at and will continue to look at to ensure that concept of best practice has been implemented in our design architectures that we promote and build internally for our team. We certainly, as Curtis just mentioned, we've taken a very clear approach to building a microservice-based architecture in our design practices, both in the cloud directly as well as at the edge. We are trying to incorporate the strategies and look at the actual, the document itself. One of the key points to me is that it offers some disadvantages or some areas to look at from the microservice-based approach that could be problematic. And so those are things that we take to heart, and we really work strongly to create new architectures that mitigate the disadvantages of the proposals that have been promoted by the different agencies, whether it's NIST or IEEE or any other body that is creating these standard reference architectures for folks like us to be able to implement. But again, as I said, this is the starting point for us. We really want to embody best practice, but then what we want to do is we want to further refine that and be able to promote that back to our colleagues in the research areas as well as the manufacturing community directly in terms of what is the next state? What is the manufacturing world look like, not just a year from now, but 5 years from now and beyond? And how do we build an ecosystem in where the research itself is extensible? So as the underlying technologies change, how should these practices themselves change? And so these are the areas that we're really focused on, and we invite all of your help and participation, because these are big issues, and we know we don't have all the answers. We're working all the time to try to continue to stay on top of the great research and the great proposals that are being submitted all the time, and to hopefully help further that bar as well with our activities. So, great question.
Excellent. Thanks, everybody. There are a couple of comments related to the RFP process. I'll frame them all together, and Greg and Wayne, I may defer to you too on these. There are related questions on any restrictions or limitations on the number of proposals that could be received. Another related question on the timeline to confirm that our first RFP will be out in about 2 weeks and due about a month after that. There was a related comment, less a question, that conveys that feels like a very short timeline. So those are all related to the RFP process.
Yeah, so I'll just summarize quickly, and it's the RFP, like Wayne said, it'll be the first time we do this. So we've kept the scope a bit narrow on the, we've asked DOE to approve a pre-solicitation notice that they haven't given us permission to release yet. So that'll provide at least a first cut at scope and scale and a little bit of timing that we plan for. We're trying to maximize the amount of time that we can give. We're not going to make it a super quick turn, but we do need to deal with how long it can take DOE to do final approval. And so I'm mindful that we want this work to yet start in presumably the fall timeframe. It means we've got to be pretty diligent about how we manage the time. So again, given this first time through, we'll be learning lots of lessons, and I'm sure it won't go quite as fast as we want it to, but we have definitely laid out a pretty precise plan, and we're leveraging really the great experience that NCMS brings to the table. They do I don't know if thousands of RFPs is quite right, but they do dozens a year. And so, someone with that kind of expertise helps us anticipate where the problems will be and how to write an RFP that's reasonable to respond to and not heavyweight. So really trying to do our homework to make it easy and straightforward to write a cogent response efficiently. Yeah, there's no particular limit in the number of proposals you make and so on. But I think you'll find that the language, the tasking language, the technical task areas are pretty specific. Hope that answers the question.
Thanks very much, Greg. And
yeah, the timing, we're hoping the timing is, early May, I think, is when it'll get released. I mean, it just depends upon DOE's approval of anything we send them at this point.
Great. Thank you, Greg. I may pass this question over to Ken Fowler for any insights, Ken, that you can share. It's a comment about virtualization and microsegmentation that the team at MISI have found in the manufacturing space to be not a foreign concept. And with zero trust, the issue is the multiple competing models, NSA and NIST as examples, as NIST. Do you have any thoughts to share related to that comment?
Yeah, I think I would piggyback on some of the comments that Jeff previously made. There are multiple competing models, as Armando mentions in his question and comment. We're going to have to continue to monitor those. Additional things we're going to have to be concerned about, right, are also with the new CMMC requirements, which will begin to be implemented later this year and for the next few years, which are going to affect anybody doing federal contracts as well. And ultimately, that's going to have a trickle-down effect, especially in the defense industrial base, which many of these small, medium, and as well as large companies are involved with as well. So we're going to have to continue to look at what is going to serve the companies, but also do the best job at securing the work that they're doing to support the nation as well.
Excellent. Thanks, Ken. And Greg, I may come back. Sorry, I think maybe the last discussion on RFP may not have. I think there's still a question out there on the timing, planned timing for RFPs. If you don't mind recapping that.
There's planned timing. It's all notional.
Yeah.
So we really can't be specific because we have no basis to know that those times will be met. I mean, it really depends upon DOE, and we have to. I mean, they're our sponsor. We follow their lead.
Well,
they have to approve stuff.
As I think most folks have heard me say many times, we submit, the document to DOE. They have to approve it before we can put it out, in any other format. They have had a pre-solicitation notice that, for quite some time. We still don't have approval to put that out on the street, nor do we have approval to put the RFP out. So as Greg says, this is, notional. We understand that. And, we're doing everything we can to put those notices out there. But we simply cannot, do that until we have approval to do so. So we'll get it out as soon as we possibly can.
Thanks to you both. And Howard, while I've got you on camera there, there's a question about the commercialization that you envision from your remarks at the conclusion. Who do you envision will be doing that commercialization?
We have high anticipation that will be some of our members, the industry members specifically. We can turn technologies over once we get them, demonstrated and validated, and so on and so forth. Like I said, we're capped at TRL 6, so to be successful, we have to work with our industry members, and I think that's a significant magnet, for companies to join the institute, because that's the mechanism that we're going to have to work out. This is not today and tomorrow, but as we develop these technologies and do the R&D that's necessary, I think the maturation definitely happens outside of, by private industry.
Thanks, Howard. Next question, Greg and Wayne, I may look to you for an initial response, and others can weigh in. The question is, as an overall structure for collaboration, do you envision a research pillar for addressing all the theoretical questions using data and research methods, and a second application pillar for applying research outcomes on the factory floor?
So I'll take the first one, and then Wayne, I'll let you take the second one. So the first one was about, will there be a pillar for, kind of more fundamental, more basic research? No, my experience in, applied science, applied research and development is you've got to keep the research close to the problem. And so, what you should see is in the baselining CEQ, there's a research aspect that would, potentially presumably be publishable in that community's research venues. Similarly for SMA, I would anticipate some Oakland and Usenix security papers and such, NDSS papers coming out of that, CCS. For SRDI, some of the more applied domains, again, Usenix security comes to mind. But no, it's not going to be a separate pillar. It's going to be integrated, because again, that's what the country needs. They don't need pillars. They really need collaborative. We're collaborative, distributed, multi-organization research, and that's what the country needs. Thank you. So
Yeah,
Wayne, you take part two.
Yeah, to build on that, right? I mean, this integrated technical approach that we've chosen, and even the labeling of research routes, right? So that's not a research pillar, but it's a route towards deployment. We have the environments that we're going to be continually integrated, relevant equipment, relevant mod and sim, relevant analytics and models, that as you're developing and as the ecosystem builds, you're really aligning it towards the applications that industry needs to see in order to deploy a new secure manufacturing architecture and do it in a formally vetted and a continuous improvement fashion. And so, our approach to this is a lot more integrated than isolating between the research community and the industry community. Really, we want the researchers to be able to be hand in hand in the muck of the research, if you will, with our industry partners, and in an ecosystem where we can quickly learn and vet things and learn from our mistakes and share our successes with the ecosystem.
Great, thanks. Thanks to you both. Sorry, Greg, did you have something to add?
No, I was just going to say, I'll respond to the CMMC question when you're ready.
Oh, absolutely. Yeah, I'll just read it briefly for the group. CMMC is undergoing a major review at DoD. Expect some changes and maybe some significant ones. The rumors are the administration is trying to make CMMC easier to achieve for small business.
Yeah, so, CMMC is, I had a bird's eye view of its development because my home institution was working along with Johns Hopkins APL and Katie Arrington as they developed that program. They were trying to, deal with the brush fire of security challenges throughout the supply chain in the DoD, as well as in the broader U.S. government in critical infrastructure. So it has a particular focus that is about, the existing systems as they are and trying to effectively defend them. We recognize that our mission is more towards the earlier in the development life cycle of critical infrastructure, of innovations. Again, as Howard mentioned, we're TRL 2 to 6 in the DOE's point of view. Certainly we're going to get engaged with industry as things move into transition, but there is kind of a focus for us that needs to stay, earlier in the development life cycle. When I talked to Ms. Arrington about CMMC and kind of how it could evolve in the coming years, it was actually one of my last meetings in DC before the pandemic. She acknowledged that she's tried to structure CMMC to be evolvable so that it can incorporate, continuous, ever better practices. So I could see the sort of design techniques that we're talking about, SMA, as well as some of the work at INL in cyber-informed in engineering. Consequence, CIE. Anyhow, I can never remember. It's got consequences in cybersecurity and engineering in there somewhere. These evolving new techniques to make critical infrastructure more robust, and we consider manufacturing to be a critical infrastructure. That CMMC will evolve there, but its focus really is on the here and now, and that is not quite what DOE has asked this institute to focus on. It's help with the here and now, but really keep your focus. How do we be in a better place in 5-10 years to make America more competitive? That's all.
Thanks very much, Greg. Just looking at the time, we probably have time for a couple more questions, but this has been excellent feedback from the group. Question, where do the broadly emerging capabilities of augmented reality and virtual reality technologies fit into the roadmap? With the example question towards SRDI and TrustWorks. I don't know if there's any reactions that you have to that question, either Curtis or Paris, on augmented reality, virtual reality. And
I think from SRDI's perspective, that's so one of the things SRDI is here to do is support novelty. No matter where that fits, where we it's a challenging problem, but we want to try to be able to support anything that furthers the ball and fits into CyManII scope. So actually, I know we've talked about this a little bit, but we're interested in particular in year one and prepping for the future, trying to figure out some of these interesting non-traditional use cases to understand what the impacts to the SRDI, the underlying infrastructure need to be. So if we come at this from a just a mindset of hey, everything's going to be a microservice, we're going to containerize everything, it's going to be software. Well, that in practice doesn't line up, right? You may have hardware-based solutions, things like augmented reality, for example, that need to be integrated. And so I think kind of first thing is identifying those different interesting use cases, and then next step is, okay, how does that integrate into the way we've designed the system? The hope is that there's no issue integrating it, and the way we're designing it now is flexible to support those types of systems as well as the underlying connectivity layer. So certainly included, and there's no intention to exclude things like that. Hopefully that answers the question.
So let me.
I can add to that a little bit as well, if you don't mind. I'll volley off of what Curtis said about certainly at TrustWorks. I think we want to be open and inclusive to any kind of emerging technologies or even mature technologies, so long as they have impact, right? I think at TrustWorks, I think our perspective is we're more interested in working with technologies and solutions from an educational standpoint that have transfer effects. And certainly there are many cases and examples of AR, VR that have been used very well in training and educational applications. So I have no reason to think we wouldn't do that, but I think my primary goal is to not necessarily be blue sky and kind of maybe look at educational solutions as NSF might look at them, but our goal is really to develop products, educational products that resonate and that have direct impact with learners. So.
So thanks, Paris. That just to kind of follow up on what's been said already, the AR/VR potential is obviously a huge future thing that needs to be taken into account in the architecture of the systems that we're going to build for SRDI. There's just no doubt about it. We look at it, we've been talking about it and bouncing different aspects of it from the standpoint of the simulation capabilities that having a VR system would allow for being able to allow researchers to get more, visceral access to the actual runtime simulations that we're creating in our SRDI infrastructural backplane. But as Paris mentioned, the opportunity to have either AR or VR systems integrated in from the TrustWorks environment to be able to successfully augment the training opportunities of the workforce, and be able to integrate manufacturing partners on how to leverage and use the systems that we're creating, which is at the sort of the engineering IT side of the manufacturing sector, all the way down into the workforce development side of being able to use these technologies in meaningful ways to help educate and promote the correct use of the technology, the secure practices that we're creating. All of those things are things that we are putting placeholders in when it comes to the SRDI development of the infrastructural design itself. And so we don't currently have explicit use cases that have been promoted that say this is something that we would like to do, but we know that what we need to do, again, to be forward thinking, is to make sure that those hooks are in place. So when those ideas do get promoted, that we know where that would be engaged, and then we can further refine how that's implemented directly in the backplane of the SRDI infrastructure.
Great. Thanks, everybody. We have definitely squeezed everything possible out of the last 2.5 hours. Great use of time from our team. I know I'll turn it over to Howard for any concluding remarks, and thank you again from the road mapping team's perspective. We look forward to engaging with you in the upcoming workshops.
Thanks, Karsten. And again, thanks to everybody for your time and all your contributions. It looks like the goals that I established have been met. You've gotten a good overview of our roadmap and where we are. And based on the number of questions coming in, it's obvious that you're likely going to engage with us in the next phase of this road mapping process. So with that, have a great afternoon, everyone, and we'll see you in the workshops.
Thank you all. Have a good afternoon.